Okay, folks, I'm going to lead you through this electrolytic cell foldable. How do we know it's an electrolytic cell? Well, there are two clues. You see, it's got a battery or a source of electricity, and it's all happening in one container or one cell. So those are the two big clues that this is an electrolytic cell. So this diagram on the front, first let's put a little zero next to Ag. That's a solid piece of silver. That's the free element. And this is a solid piece of copper. And so what we are going to do with this electrolytic cell is we are going to electroplate silver onto a piece of copper. All right, now it's important to know what mnemonic devices you can always count on for any kind of cell, an electrolytic cell or a voltaic cell. It will always be true that anox and big red cat will help you. Anode is where oxidation happens, and reduction is where the cathode happens. The cathode always gets bigger. We'll talk more about that later. Leo the lion says grr. Loss of electrons is oxidation. Gain of electrons is reduction. And electrons always go alphabetically. They always start at the anode. They go to the cathode. All right. There are a couple of things that are special about electrolytic cells, or kind of backwards, okay? On an electrolytic cell, the table J rule is backwards. The table J rule is flipped. In a voltaic cell, the higher metal will oxidize. In an electrolytic cell, the lower down metal will oxidize. In an electrolytic cell, the anode is positive and the cathode is negative. Usually, or in a voltaic cell, anode and anion are negative and cathode and cation are positive, but it's backwards in an electrolytic cell. Okay, first have a look at table J and use anox to figure out which metal is going to be the anode, remembering that the table J rule is backwards. Okay, we've got copper and we've got silver. Okay, in this case, in this electrolytic cell, the lower down metal is going to oxidize. It's backwards from the voltaic cell table J rule. That means that the silver side will be the anode where oxidation occurs. Again, the lower down metal oxidizes for an electrolytic cell. That means that over here on the right, the cathode will be the piece of copper. That's where reduction will happen, because anox and red cat are true everywhere. Okay, the electrons go from the anode to the cathode. And I just added Leo here on the anode side and grr here on the cathode side. The loss of electrons is oxidation. You can see we are losing electrons from the anode and they are going up the wire to the battery. We are over here gaining electrons at the copper cathode. Where are those electrons coming from? They are coming from the battery. So on the left side, we are losing electrons. On the right side, we are gaining electrons. And the flow of electrons through the wire follows that pattern. And they always go from anode to cathode. Okay, let's label this little ion here as an Ag+, because the half reaction on the anode side is oxidation. So Ag0 must be changing to Ag+1. That is an oxidation, a increase in the charge. Reduction would be a decrease in the charge, becoming more negative. In this reaction, we're producing electrons. We've got an electron that is the product here. Where do those electrons go? They go up the wire. So you can see that all these different parts fit together and kind of match up. Over on the right side, what's happening with the copper? The half reaction over here is Ag+, plus one electron makes Ag0, solid atoms of silver. You could put a little zero next to each of these little Ag atoms that's attached to the copper zero. Where do those electrons come from? They're coming down the wire, joining up with an Ag+, forming an Ag0. Okay? I want to emphasize that the anode, which would be negative in a voltaic cell, the anode is positive here, and the cathode is negative, because that is flipped from a voltaic cell. This is an electrolytic cell. All right, let's fill out the inside of the chart. On the anode side, electrons are pulled up the positive side of the battery, and when those electrons are lost, it causes the neutral silver atoms to become silver ions. Those Ag+ ions float into solution because they're no longer a part of the solid Ag metal. So over on the cathode side, electrons are pushed down through the wire from the negative side of the battery. Those electrons attach to the Ag plus ions that are in solution. The Ag plus ions gain the electrons, creating solid Ag0 atoms, which attach to the copper ring. So what's happening to that copper ring? It's getting slightly bigger because Ag, or silver, is being plated onto it. We are electroplating silver atoms onto a piece of copper, and it literally gets bigger in mass. It gains atoms. That means over on the silver side, that silver electrode is getting smaller because the silver atoms are turning into silver ions and floating off into solution. What's going on in the solution? Well, it's an ionic compound. You have to start off with some kind of ionic compound. Probably AgNO3 would be a good one to use. Then that way you can conduct electricity through the solution right from the very start. Okay, thanks for watching, and this concludes this electrolytic cell foldable.